Assalamualaikum everyone. I'm Mahfuz Hassan and today I will take you through how containerization and Docker have become the foundation of modern software delivery. Think of this as a behind the scene look at how tech giants like Google or Netflix deploy updates in seconds with zero downtime. That's the power of containers. Let's start with the basics. Containerization is all about packaging an application with everything it needs, code, libraries, dependencies, into one neat portable unit called a container. Unlike traditional virtual machines, containers don't carry a full operating system. They share the host OS kernel, making them lightweight, faster, and far more efficient. In simple terms, if virtual machines are like shipping trucks, containers are like small standardized shipping boxes. They deliver consistency from development all the way to deployment. Here is a quick comparison. Virtual machines each run their own OS, which make them heavy and slow to start. Containers share host OS, so they are lightweight and launch in seconds. The result? Containers use fewer resources, which make them highly portable. On the other hand, VMs have limited portability. That's why containers became the backbone of modern cloud system. Agile, efficient, and built for speed. Now, why does this matter in DevOps and cloud environments? Because containers bring automation, consistency, and speed. They fit perfectly in CI/CD pipelines, allowing teams to build, test, and deploy continuously. If a version fails, it's easy to roll back. And since the environment is same everywhere, from a developer's laptop to production cluster, you eliminate the classic "it works on my machine" problem. This is exactly what makes containerization essential in DevOps culture. Containerization didn't appear overnight. It evolved over decades. In 2000, FreeBSD jails introduced process isolation. In 2004, Solaris Jones improved that model. By 2008, Linux container brought OS-level isolation into the mainstream. This milestone paved the road for what we use today, Docker. Docker changed everything. Introduced in 2013 by Solomon Hykes and Cloud, Docker simplified complex Linux container technology into tool developers could actually use. Then it became open source and adoption skyrocketed globally. Today, Docker sits at the heart of DevOps, cloud computing, and Kubernetes, powering almost every modern development pipeline. Here is a quick look at Docker architecture. We have three main parts here: Docker client, Docker host, and Docker registry. Docker client is a CLI where user can interact with Docker engine with Docker command like Docker build, Docker pull, Docker run, etc. And Docker registry is a public or local repository where Docker images are stored. And under Docker host, we have Docker daemon, which is the core of Docker engine. It pulls images from Docker Hub, builds them for Docker files, and manages everything through Docker CLI or API. This simple yet powerful design is what makes Docker both developer friendly and enterprise grade. Let's have a look at some essential Docker commands. Docker run a container. Docker ps, list running containers. Docker images, show local images. Docker pull, download images. Docker build image from Docker file. Docker exec, run command inside container. Docker stop container. Docker rm, remove container. Docker logs, show container logs. Docker inspect container details. These are from backbone of Docker operations. One challenge with Docker container is that they are temporary. Once stopped, their data is gone. That's where volumes comes in. They store data persistently outside the container and can even be shared between containers. There are two main types: named volume, managed by Docker, and bind mount, which is directly linked folder from your host machine. Volumes make container not just fast but practical for real-world application. Next, networking. Docker offers several network types: bridge, the default for container-to-container communication; host, which share the host network stack; none for isolation; and overlay, which enable multi-host networking for tools like Swarm and Kubernetes. In short, Docker networking decide how containers talk to each other and the outside world. To wrap up, containerization has revolutionized how we build, ship, and run applications. Docker made that revolution accessible to everyone, from startup to global enterprise. It is now foundation of DevOps, CI/CD, cloud native architecture. So if you care about efficiency, portability, and scalability, containerization is not optional. It is essential. Thank you everyone for joining. You can find the official documentation to install Docker in this link, and here is the OS requirements, and then here is the config file you can remove with this command. And as you can see, there are various installation process, and I am going with the easiest process, which is the install using convenience script. The command is here. Now I will install Docker in my Ubuntu machine. I am updating the Ubuntu server now with this command, and then I will install curl. Curl is already installed in my machine. Now I will download the shell script from get.docker.com. This is the command. Now I will run the shell script to install Docker in my machine. As you can see, Docker is installed. The info is showing here. Now I will verify the installation with this command, docker --version. But the version is showing. Now I will check the status of Docker. It is active and running. Now I will check the Docker info. Now let's run hello world. It is showing hello from Docker, which means the image is run perfectly. Now I will create a Docker Hub account. You can see the sign up button. You can sign up with various kind. I already signed up, so I am logging with my account. This is your Docker Hub dashboard. Now I am logging with my Docker Hub account from Ubuntu machine. With Docker login, you can see a one-time code is generated. You have to verify the code from your browser. I am putting the code and click confirm. As you can see, login succeeded. Now I am logging with my username, which is the easiest way. putting my password here and then press enter. You can see login is succeeded. Now I will pull some image from Docker. First Docker Nginx, then pull MySQL, then I will pull Redis, and then I will pull Mongo, then I will pull HTTPD. You can see all the images is pulled successfully. Now I will check the images with Docker images. Now I will run Nginx with 8080 port, and then I will run Apache in 8081 port. Now I will check then I will create a Docker volume, name my data. The volume is created. Now I will run MySQL with this command, giving the root password. And giving the path here. Now I will inspect the volume. Now I will check available Docker networks. Then create a network named mynet. Now let's run web under mynet. Then let's also run MySQL under mynet. Both are under mynet. Now I will ping using exec. You can see it is ping successfully. Now I will check Docker history of Nginx. Now I will check the Docker log for my Nginx. That's all. Thank you everyone.